Yeah, camps on everyone. Let's start off. The last thing that we did was this one, the ring on a rod. Hope everyone has gone through the notes. Let's start off. Others to keep your cams on. Next thing, the radius of curvature. So what is this radius of curvature? So what if every time, see, you won't see particles going in a circle. Sometimes they'll go in some weird paths also. So in calculus, if you remember, we can study a curve is nothing but a segments of small lines. We have seen these kind of questions, in friction and NLM. What we used to do in these kind of questions, we used to take the small curve. We used to say this is ds, this is dx, dy. So we basically treated them like a straight line. Similarly, you can do the other way around. You can treat each segment of a curve belongs to a part of a circle. Segment of a curve can be treated as a part of a circle. And the radius of this circle is called the radius of curvature at that point. If you ever go to Imagica, right, if you see that Nitro car ride, in, in an amusement park, if you see the rides are like this. So what they do, if you actually closely observe, this each part is actually a part of a circle. So they bring different parts of a circle and they assemble them. You don't actually get a curve. Same thing tomorrow when you're writing a program, or when you're telling a drone to fly in a circle, or when you're telling a drone to fly in some kind of a curve, the drone does not know what is a curve. So what you're actually doing is you're constructing the curve using parts of a circle. This is something which they do in the metro also. If you ever think about a metro, whenever the metro is taking a turn like this, so this segment will have a particular circle. This will be a different circle. And this might be a different circle. So each section has a different radius of curvatures. And when you combine them, you get the curve you want. So example, let's say something is like this. Something of this sort. So at this point, if you take a small segment, this thing belongs to this circle. This segment belongs to a bigger circle. This segment belongs to this circle. This segment belongs to this circle. So each segment has different radius of curvatures. So in real life, when someone asks you to construct a curve, right, we don't know how to construct a curve. What we do, we try to break that curve into circular segments and then we manufacture them accordingly. Because manufacturing circles is easy. If you ask me to construct a parabolic track, it is difficult. So what people do, right, generally is like they construct this thing, they treat it as a part of a circles. Cost effective, nothing much. So if you take the small segment ds, there. So ds, right, can be treated as a circle or an arc. You can do both. That is the whole advantage of your calculus. So a curved path can be treated as an assembly just give me a minute. I think my PC crashed. Able to hear me, right?
Yes,
Okay.
sir.
Yeah. Someone said something? Okay. So a curved path can be treated as an assembly of small arcs or small lines. Both are acceptable as long as radius is small. Clear with this? So for a circle, there is no problem. Radius of curvature is the radius of a circle. But if you have dealing with curves, some random curve, then every point the radius of curvature will keep changing. So how do you find this radius of curvature? So let's say if a particle has velocity v and it has acceleration a in some random direction. If this angle is theta, you can resolve this velocity into two parts. So keep the velocity as it is and resolve the acceleration. This will be a cos theta, which is perpendicular to the velocity. This is your a sine theta, which is parallel to the velocity or anti-parallel. This is your centripetal acceleration. So basically a cos theta is the one responsible for changing your direction. So the acceleration perpendicular to velocity is your a centripetal, and this is responsible for changing your speed, and that's your tangential. Isn't that how we define tangential? The component of acceleration responsible for changing speed is your tangential acceleration, and the acceleration which is responsible for changing direction is your centripetal acceleration. So if something is going in a curve like this, if this is your velocity, we'll have a centripetal and we have a tangential. It could be in the other direction also. So basically this a centripetal will be towards the circle. So keep this in mind. Whenever they ask you to find the radius of curvature, don't touch the velocity. Keep it as it is. Resolve the acceleration. And then, so a centripetal will be nothing but v square by radius of curvature. So from here we get radius of curvature is nothing but v square by a centripetal or v square by a perpendicular component. There. This is one way to find radius of curvature. Straightforward formula. Then the centripetal acceleration v square where that r is the radius of curvature. Have a look at this. Clear? Let's see a question based on this. Any doubts on this? Please ask me. So we have a particle projected with speed u and theta. Gravity is there. Find a centripetal. Your kinematics is back. A tangential and radius of curvature. When velocity vector makes an angle alpha with the horizontal. So in case you're wondering what I'm asking, this is what I'm asking. So as this particle goes in a parabolic path, at some point it will have some velocity, it will make an angle alpha. At this instant, what is the A centripetal, A tangential, and radius of curvature? So you can treat this parabola as a part of a different circles. So I want the radius of curvature of that thing. Let's get this. It's a good one. They can ask you multiple things. The radius of curvature is proportional to alpha in what way? How does the radius of curvature change? It will increase, it will decrease, increase and decrease, decrease and increase. What is the minimum radius of curvature? So a lot of things can be asked. Try for 2 minutes, and I'll show you the whole thing. And they can even ask you a function of time t. Hmm. Right, Siddesh. Right, Arya. That looks right. Let's see. Let's see. See. This is V here. At some angle, it will make alpha. Remember, I don't know the value of V yet. And what is the acceleration? This is G. So if you try to resolve this into components, you will get that's alpha. This will be 90. This will be 90 minus alpha. I'll resolve that. See. This is 90. This is 90 minus alpha. So the components will be, this will be G cos alpha. G cos 90 minus alpha, and this is G cos alpha. There, those are your components. There, it is easy then. Your A tangential is G sin alpha. A centripetal is G cos alpha. And we know A centripetal is nothing but V square by radius of curvature, which is G cos alpha. So radius of curvature will be V square by G cos alpha. But what is V then? We know in a projectile motion, the horizontal velocity is same. The U cos theta will be V cos alpha. This is how you find B ka value. V is U cos theta by cos alpha. Let's say they ask you to find as function of time t, then there's only one formula for alpha and time. Tan alpha will be U sin theta minus GT by U cos theta. So if you substitute here, this ends up to be U square cos square theta by G cos cube alpha. There was a question like this once. The radius of curvature is proportional to what? 1 by cos alpha, 1 by cos square alpha, 1 by cos cube alpha, 1 by cos power 4 alpha. Check. There we got everything. Radius of curvature, A tangential, A centripetal. If you actually observe this thing here, when this is going in a parabola, initially the radius of curvature is pretty big. As you go up, the radius of curvature decreases. At the highest point, you have the minimum radius of curvature. And then again, it increases. So at the highest point, the speed is minimum, U cos theta. And the gravity is maximum, GH. So at the highest point, there's no tangential acceleration. The radius of curvature will be U square cos square theta. So there. So at the highest point, your radius of curvature is, the speed is minimum and the acceleration is maximum. The point of projection radius is maximum. So if they ask you a theoretical question, the radius of curvature decreases and then increases. So you can play around like that. Clear? Easy, everyone. There, your kinematics and circular motion if you combine everything there. Next thing. Let's say we have a parabola here. Y is equal to x square. Here we have a ring inside. This is a parabolic wire. So what happened? Someone is pulling this ring with a horizontal speed u. What is the meaning of that? When the ring is here, the horizontal speed is u. When the ring is here, the horizontal speed is u. The ring is going with some other speed. So here the speed is v1. Here the speed is v2. So the speed of the ring is changing continuously, but the horizontal component remains same. Ring of mass m slides on a parabolic wire with constant horizontal velocity. Remember, the speed changes, but the horizontal component is constant. Find A centripetal, find A tangential, find radius of curvature at 0.1, 1. So when this ring reaches 1, 1, find the A centripetal, A tangential, and radius of curvature. Hope the question was clear. You got a parabolic frame. Someone is pulling this ring in such a way, the horizontal velocity is u. What is the actual speed of the ring? We don't know. So there are external forces acting on this ring, or else it won't go like this. So how that is happening, don't worry about it. It is happening. It's going with the horizontal velocity u. So find the centripetal acceleration, tangential acceleration, radius of curvature when it is at 1, 1. Try. Give 2, 3 minutes.
तो ग्रेविटी वगैरह सब है ना.
It doesn't matter. Gravity doesn't matter. Even if it is there, it is not there. To root fifth. Okay. I asked you to find centripetal acceleration and A tangential. What are you finding, Shaurya? Okay. Try. Everyone should try. It's fine if you don't get an answer, but give it a try. That's important. Let's see. By g root 5 over u square by root 5 g root 5 to z by root 5. Okay, people got different answers. Okay, let's see. So this ring, when it is going, now there is one thing that is given: the horizontal velocity is constant. Great. So your velocity, horizontal velocity, Vx is u. Vy, we don't know. So that is giving you the net speed V actually. Okay. So what is your x coordinate? X coordinate is u into t. Because since the horizontal velocity is constant, I can directly let x is equal to ut. If x is equal to ut, remember the equation y is equal to x square. So the y coordinate will be x square, which is nothing but u square t square. Is that making sense, everyone? Dimensionally, it will look wrong because this y is equal to 1 into x square. This 1 actually has a dimension. That is 1 by length ka dimension. So I should have written y is equal to ax square. But ठीक है. So be careful. If you try to match dimensions, you will not get an answer here because I didn't give the dimensions properly there. And there you got the y coordinate. So if you differentiate this, we will get Vy, which is dy by dt. This will be 2u square t. So this is your vertical velocity at any time t. Vx is u, ax is 0, ay is dvy by dt, which is 2u square. Therefore, speed at any instant will be root over vx square plus vy square, which is u square plus 4u power 4t square. This is your speed at any instant. And you're asking when the at 1, 1. So, okay. When x is equal to 1, time will be 1 by u. So at 1, 1, the speed will be root over, that is 1 by u square root 5 mu. This is the speed when it reaches 1, 1. Any doubts still here? So if you see this ring, it has only a vertical acceleration. It has no horizontal acceleration. Speed we got. What did I ask you though? A centripetal, A tangential, it is a curvature. Great. So y is equal to x square, the slope, which is tan theta, which is nothing but dy by dx. So tan theta will be equal to 2x. At x is equal to 1, tan theta is equal to 2. That means when this particle reaches 1, 1, if you try to draw a tangent, it makes an angle theta. And this thing has an acceleration in the vertical direction a. And it has a velocity in the tangential direction. This is your velocity v. This angle will be 90 minus theta. And this angle will be 90 minus theta. There, just now I told you, the components along the velocity is tangential, perpendicular is a tangential. So I'll just draw the picture here. This is v. This is a net acceleration a because there is no horizontal acceleration. This angle is 90 minus theta. This component will be a cos 90 minus theta, which is a sin theta. And this is your a tangential. This will be a cos theta, which will be a centripetal. So a centripetal is a cos theta. A is nothing but 2u square. A net is root over ax square plus ay square, which is 2u square only. 2u square, and I hope you remember how to get cos theta and sin theta from tan theta. Make a triangle. This is theta. Tan theta is 2, 1, and this is root 5. So cos theta is 1 by root 5. A tangential is a sin theta, which is 2u square into 2 by root 5. And what is your radius of curvature? Radius of curvature is v square by a centripetal. So that is the reason you need the speed v actually, because you need full speed. What is the full speed? Root 5u ka whole square, and a centripetal is 2u square by root 5. U square goes off. You end up with 5 root 5 by 2. That's your radius of curvature. Check your steps. Right, Samyak. Right, Anita. Ovia, you आएगा नहीं रे. How did you get G actually? G है ही नहीं picture में. See where it went wrong. Play with this. You can try it on your own, Arya.
Sir, I'm not
You have an idea.
understanding.
Then don't do it now. Then don't do it right now. Think about it for 1 or 2 days and then come back to me with your working. You have an idea, good. Then you should think about it. What are the points? Why are you so impatient that you want an answer within a minute or two? And why do you think that will even give you an answer in the first place? So think about all that things, na? That is important. Don't run behind an answer. Any doubts on this? Understood what we did, everyone? So first thing, the whole thing started with this part here. Constant horizontal velocity. If you don't use this, you can't do anything. Since the horizontal velocity is u, the x-coordinate will be ut. If I know the x-coordinate, I know the y-coordinate. If I differentiate y-coordinate 2 times, I'll get acceleration in y. If I differentiate once, I'll get velocity in y. Vx I know, ax will be 0. So once I got this, I actually know everything about the particle. I know the velocity, I know the acceleration. At 1, 1, I found the time. I found the speed when the particle is at 1, 1. I also found the acceleration when it is at 1, 1. Acceleration is in the vertical direction. Remember, velocity will be always tangential. Velocity is always tangential to the path. I think once you got till there, I think you're done. Once you know V and U, you got everything. Clear with this? And if you observe, there is no need for a G there. Even if G is there, the meaning is this. This acceleration 2u square is coming. That means there is some force here, F, which is doing something. We don't know what it is doing. It is balancing this normal reaction. It is balancing this mg. There can be even friction also. I don't care. That external force is taking care to make it go with a horizontal velocity u. So don't worry about that. All clear with this? It's a good one. Let's see a more standard question. This is important. You can put a star. This has been asked multiple times in mains and all other exams. And you can expect again. So whenever I say standard question, remember, you'll not be giving a single exam. You'll give almost say 8 to 9 exams. 2 mains, 2 bits, CET, Manipal, Vellore, UG, advanced. So question will pop up somewhere. So we got a track like this. The picture is up to scale. Matlab, if it's a long, big curve, it's a big curve. It's a sharp turn, it's a sharp turn. It's like a roller coaster ride. So on this, we have a block of mass m, which is going with a constant speed u. Again, there are some other forces which are maintaining it. We don't know how. There are 4 points here, A, B, C, and D. Gravity is present. goes on a curved track without losing contact. So it will not fly away, okay? With constant speed u. So it is going with a constant speed. Speed is not changing. So arrange the normal reaction at A, B, C, D in descending order. So there will be a normal reaction between the block and the floor at the 4 points. Let's get this. I hope the question was clear. The vehicle is going in this random curved path with constant speed u, mass, and gravity is there. What is the normal reaction between the block and the floor at these 4 points? We don't want the values. We just want who is bigger and who is smaller. Let's get this. Hmm. Everyone should try. Try. Give you a minute or two. It's a good one. Let's give it a try. See, we have already one answer from Arya. Right, Arya. Right, Samya. Siddesh. We all got it. Ishman, that is wrong. Let's see. If you ask me normal reaction, first thing what to do? Start with the free body diagram. Because nothing will give you a normal reaction other than free body. So what are the forces? This will be your normal reaction Na, your own weight mg. Remember, this will be like a circle of this sort. Centrifugal force is away from center. So this will be m u square by Ra. So normal reaction here will be mg minus mu square by Ra. When it is here, This will be NB. This will be mg. Centrifugal force away from the center, mu square by RB. NC, mg. This is your radius of curvature, which is mu square by RC. So you can clearly notice here, whenever you're going down the valley, the centrifugal force and mg will act in the same direction. When you're going up the hill, the centrifugal force and mg will oppose each other. So when you're actually going in a roller coaster ride, right? When you're going like this and going into the valley, you'll experience your weight has increased by around 2 to 3 times. And when you're going up the hill, you will feel your weight has decreased to g by 2 or half the weight. So this continuous fluctuation of your weight, so your weight is fluctuating between, your weight is becoming 1/3, your weight is becoming 3 times. So your body is continuously under stress. So it starts releasing adrenaline and all other hormones to protect you. So your body is crying, boss, I'm dying, but you think it is excitement. Getting it? So that's what happened actually. Some people, right, their tolerance level is less, so they get scared. Some people, for them, it is like, okay, fine, it is nice. So that excitement and the rush you feel is because of that. And next time, observe this, when you go to an amusement park, this is what happens. So as this thing, whatever the vehicle is coming, people are shouting, if you see there's a gap in the middle, ever observed it? They are shouting continuously, when there's a gap in the middle. Ever observed that? If you have
Yes, sir.
not, next time when you go to an amusement park, observe that. So you will observe the sound gets cut off when they're at the lowest position. What happens is when they're going with that high speed in the lower part, the gravity, they will feel the gravity has become 2 to 3 times. The air is pushed out of the lungs momentarily. And when there's no air in your lungs, you can't make a sound. So people become quiet. And then when they're coming up again, they'll breathe in and then the shout will come. So, or do you think everyone is in a sync? They all decide at the lowest point, let's not shout, be quiet. They don't synchronize it, right? So it happens automatically without you thinking. So, and then what is NC? Mg minus mu square by RC. And what is ND? Mg plus mu square by RD. Right? So from here you can clearly see. Just have a look at this. So now you can clearly see here at the lowest positions we have more thing. So one thing is clear, NB and ND are greater than A and C. Now who is bigger? You can clearly see since radius of curvature RD is much smaller than radius of curvature at B, mu square by RD must be greater than mu square by RB. Therefore, normal reaction at D is greater than normal reaction at B. That is clear. Similarly, RC is less than RA. So mu square by RC is greater than mu square by RA. But remember, what I want is mg, this is a minus sign there. So mg minus mu square by RC will be less than mg minus mu square by RA. Therefore, NC is less than NA. So great. So your answer will be D is the highest, B is next, C is next, A is next, C is the last. So at C, there is a high chance you will fly away. So the normal reaction at C will be minimum. So sharper turns will give you more acceleration. Right? Sharper turns will give you more acceleration. The broader turns will. So this is the thing actually what happens, when you're going on a vehicle. If someone has a very long turn, you won't even feel the sensation. But when you try to take a sharp turn, you actually put a lot of stress on the vehicle and yourself. So sharp turn, and that is the reason most of the times you will skid also. Next time, try to do that when you're going on a cycle and there's a curve. If you try to take a sharp turn, you have to bend more. If you don't bend, you will skid. So it's a pretty good question. Definitely remember this. It will pop up in some other exam, mains level question. That's a good one. Clear? Right over here. Next thing. So there is a way to do this. So if you just want only to find radius of curvature, right? Now again, this is not in the portion, but there is a mathematical way to find the radius of curvature. So it's better if you remember, it will be useful. Sometimes the question is only based on radius of curvature. This will help. But then again, this is not there in the portion. So whatever question they'll give, they'll expect you will solve using v square by a centripetal. So let's say we have some random path. You take a small segment ds. This is small d theta, and this is the radius of curvature r. Now, like I said, you can also treat this ds like a straight line. You can treat this ds also like an arc. So this is dy and this is dx. So ds is root over Pythagoras theorem, dx square plus dy square. So ds can be written as r into d theta, arc length. Take out dx common. You end up with 1 plus dy by dx ka whole square. So from here we get r is equal to dx by d theta. One plus dy by dx whole square. But we already know tan theta, that's your slope, is dy by dx. If you differentiate on both sides, we get sec square theta d theta by dx. So differentiate this with respect to x. It's more of a max. It's not important. The result is only important. Derivation, no one will ask you. They won't even ask you this thing in the advance. If at all they want to ask you this, they have to give you this formula before. But it is useful. Let's say I'll show you for questions like this. If they just ask you radius of curvature, instead of doing all this story, this one formula will give you the answer. Sec square theta d theta by dx will be d square y by dx. That's a double differential. So if you substitute this here, this is an arc actually. And sec square theta is nothing but 1 plus tan square theta. And tan theta is nothing but dy by dx. Let me the next page. There, you get a formula like this. So the radius of curvature, the formula is 1 plus dy by dx, the first differential ka square, whole power 3 by 2 by d square y by dx square, the double differential. This will give you the radius of curvature for any 2D path. Remember this, useful, saves you time. If you're doing questions from Merido, you'll need it. Put a mod. It's a magnitude. The radius of curvature ka sign simply indicates the concavity, convex or concave. So, example, let's see this one. Y is equal to x square. So if you take this point here, 1, 1, that was the question which we did. So we want to find the radius of curvature here. We had to do so many things to find the radius of curvature, but if I know this formula here, dy by dx is 2x. D square by dx square is 2. So radius of curvature will be 1 plus 2x whole square, 3 by 2 by 2. You wanted x is equal to 1. And that will become 5 power 3 by 2 by 2, which is 5 root 5 by 2. Same answer, right? There. You can skip everything and get the answer with the radius of curvature. Yeah, but if they ask you for a centripetal and a tangential, you had to do all that.
So can you go to the previous page for me? Got it, sir.
Clear, everyone? Let's see a question based on this. You can note down that formula. You will need it. Yeah, let's see our question. Remember this again, we're going to do this in work power energy again. So we got a path here, which is y is equal to x cubed by 3. There is a block here of 10 kg. Going with the constant speed of 10 meter per second. Friction mu is equal to half. A 10 kg block slides on a rough curved path. With a constant speed of 10 meters per second. Find the frictional force at 1, 1. So find the frictional force acting on the block when it is at 1, 1. It is applicable to this. If you see, I proved it for a random curve, isn't it? I didn't take any equation specifically. Let's see, get this. Gravity is there. I can even ask you, what is the external force? Find the external force, which is actually dragging this block. This block won't go on its own with a constant speed. There is some force which is dragging this block up. So I can even ask you that question. Find the external force acting on the block at 1, 1. No, sure, that is wrong. Think. I'll give you 2-3 minutes. This is a good one. So you will need that formula. Let's see. 275 root 2 Siddesh. That looks right. I think Siddesh got it. Let's see. See where you're goofing up. You were missing up maybe one force. The most common mistake what people do, they actually forget the centrifugal force. Now understand, when this particle is going on a curve, it's actually going on a part of a circle. So when I draw the FBD here, there are a few things you have to take care. So it behaves like an incline. Theta, and this is your tangent. The slope will be dy by dx. Here y is x cubed by 3, so that's x square. So tan theta is equal to 1 because at x is equal to 1. So theta is 45 degrees. So at that instant, the block will feel as if it is going on an incline of 45 degrees. Now, what are the forces? Normal reaction, mg cos theta, mg sin theta dragging you back. Since it is going up, there'll be also friction backward. There'll be also an external force, which I didn't ask you, but there is someone who's pulling it, or else it won't go on its own, right? This is there. And since you're going in a circle, we also have a centrifugal force, which is mu square by r. You can even write centripetal acceleration, anything will do. So the most common mistake what people do, they think normal reaction is mg cos theta. No, n is mg cos theta plus mu square by r. Maybe you did that mistake, check it out. And what is friction? Since it is slipping, F is maximum, which is mu into n. So far, great. So if you look at the problem here, the issue is, I know everything except R. So this is mu mg cos theta plus mu square by r. Now, if you don't know that radius of curvature formula, you will not get this problem. So what is this radius of curvature? R is 1 plus dy by dx whole square, whole power 3 by 2. So what is dy by dx? X square. And what's the double differential? 2x. You wanted x is equal to 1. So radius of curvature will be 2 power 3 by 2. So root 2, that is your radius of curvature. I think you got everything. So this is half. mg is 100, cos 45 is 1 by root 2 plus. This is half. This is 10. V is 1000 by root 2. That is 50 by root 2. This is V square now. That is 100 actually. 500 by root 2. 550 by root 2 Newton. So if you had forgotten that mv square by r, you would have ended up with the 50 by root 2 there. Check. That's your answer. Clear with this? There. If I ask you friction, normal reaction, you have to start with your free body diagram. Once you draw the free body, so this is the thing that you need to remember. If you are going in any curve other than a straight line, actually when you go in a straight line, also there's a centrifugal force. A straight line is a circle whose radius of curvature is infinity. So the centrifugal force will be mu square by r, which is mu square by infinity, which becomes 0. So think of like this. There is always the centrifugal force. Even when you go on a straight line, you have a centrifugal force. Then formula V is the initial velocity. V is the tangential velocity, na? And I said it is going with a constant speed. So it's always the same. Right over here? All clear with this? Take a break. Come back by 9:45. We'll continue from here. Any doubts so far? Chalo, come back by 9:45 then. Yeah. Camps on everyone. So that's a bit about the radius of curvature. So technically with that, we are done with the thing, but there is, like I said, J advanced merit means me, I think this is the stuff, but if you remember, there's a formula we derived actually. When your rotating observer actually has these four accelerations, this was the formula that we derived. So acceleration was d square r by dt square minus omega square r cap. This was your radial acceleration. R alpha plus 2v radial omega theta cap. This we derived at here. This was the acceleration cutoff, page 45. So let's see a few problems on this, one or two problems. We'll see two models on this just to get a hang of it. Because JE people, right, they have a habit of doing such things. They will give you a question, they will give you this formula and they'll ask questions. So better we be prepared a bit. Because this formula, right, they'll not expect to derive, they will give it generally. Other scams on? Keep your cams on during the session, or else I'll just remove you from the classroom. I'll put you in a waiting room. So now for simplicity, right, every time you're writing the d square r by dt square, I'll just make it a little simpler. So we'll just put a r dot dot. So generally r dot implies first differential. R double dot is d square r by dt square, double differential. Just to keep it little easy. So that's actually to r dot omega, but which is v radial. Hope you remember what is r cap and theta cap. In case you don't remember, I'll just brief that also. So r cap is the direction away from the center. Theta cap is the direction which is tangential. Polar coordinates basically. You can note down that formula. We will need that. Put it on in case you don't remember. Let's see. So we have a pulley here. We have a mass capital M. We have another mass here, small m. At this instant, this is given velocity v vertically. This is theta. This length is L. Gravity is present. You're getting how is the scenario? There are two balls. So one is capital M and one is small m, point masses. This small m is given velocity v. Speed v vertically as shown. That length of the string is L. The other one is capital M. So at this instant, now next moment, what happens that we don't care. Things will start getting messed up. The length will change. The blocks will move. Everything will happen. At this instant, find first question, acceleration of capital M. Angular acceleration of small m. Because if you actually try to study the motion, after some time, this capital M will come down. It can go up. Anything could have happened. And this guy would become like this. So this thing is actually swinging, isn't it? But small m is swinging and the radius is also changing. So both the things are happening at the same time. Angular acceleration alpha of small m at this instant. Let's see, how will we find this? I mixed up everything. I'll give you a simpler version of this question also, but let's first try this. Think for 2 minutes. Whatever you think, you do it, then I'll show you. And do remember, this formula will come for things which are going in a circle. That means for this capital M will only go up and down. So that won't have any circular accelerations, but this guy will have all those circular things. So small m is going in a circle whose radius is changing. Capital M simply goes down or up depending on the values. So take 2 minutes, just write whatever equations you can and don't worry about right or wrong. Start with the free body diagrams. So first of all, let's see, if you take accelerations, let's take capital M FBD. What are the forces? Tension, capital Mg. It is going up, so that will be d square r by dt square. That's your basically acceleration A, which we'll simply call as r dot dot. So this will give you equation T minus capital Mg is equal to m into r dot dot, which is your acceleration. And when you take this small m, remember small m is going in a circle. What are the forces? Tension, mg, and in this direction, the radial acceleration. What is your radial acceleration? This was the formula, isn't it? R dot dot minus omega square R. So if you see that capital M didn't have this part because it's not going in a circle, there's no omega defined for it. But for this guy, R dot dot and both are defined. So we have an acceleration in this direction, which is R dot dot minus omega square R. That only, if you see omega square R is the centripetal acceleration towards the center and R dot dot is away from here. So here, if you write this equation, this was your theta. And what about the velocity components? This would be V cos theta, and this would be your V sin theta. This is your V tangential. This was your V radial. And omega is nothing but V tangential by radius. In this case, it's V sin theta by L. V radial is V cos theta. We will need that. Perfect. I think we have everything we need. That's theta. So this is theta. So for this, the equation will be T mg cos theta minus tension is equal to mass into acceleration. So acceleration will be R dot dot minus omega square R. Perfect. I think we got everything we need. So take tension from here and substitute this. This will be mg cos theta minus tension. That will be minus capital Mg plus m R dot dot. So I'm actually trying to find that R dot dot. That's your acceleration, which is m R dot dot minus m omega square R. So bring all this R dot dot to one side. Mg cos theta. I show this in a much faster way. Minus capital Mg plus m omega square R. You know everything here. So R dot dot, this is the acceleration of this. This will be mg cos theta, which I know. Capital Mg we know. M omega square is nothing but V sin theta by L cos square, and this is L. That also we know by m plus n. There, we got R dot dot. This is the acceleration of the thing. Technically, this is how you do, but there's a faster way to do. You guys remember in NLM I taught you something, net pulling force method. So if I try to use that, this is capital M, this is small m. Think of like this. So this guy is getting pulled down by mg. Let this be acceleration A. This is being pulled by theta, which is mg cos theta. Plus, since you're going in a circle, there will be also centrifugal force, which is m omega square L. So let this be acceleration A and let this be acceleration A. So the net pulling force will be m omega square, that will be small m, small m omega square L, that's the centrifugal force along the string, plus mg cos theta. These both are together pulling the thing down, and mg is opposing you by the total mass is m plus n is your A radial. Didn't we get the same answer? Mg cos theta, this is m omega square r, mg and mg done. Even if you don't know all that formulas and all, you can still get this part. Is this making sense? So for the capital M, mg is pulling down. For the small m, there are two forces which are pulling it down, mg cos theta and the centrifugal force. So you can say centrifugal force plus mg cos theta are pulling down and mg is opposing. So this is a net pulling force. So there, you need not do all that stuff. You would have got the answer either way if you just wanted acceleration. Clear with this? Any doubts on the steps? So depending on capital M, small m, the signs will take care of themselves. If capital M is very heavy, then A radial will be downward direction. If it is light, then it will go up. The question is still not over. We need to find alpha. How would you find alpha? What is the angular acceleration of small m? Any doubts on this page, please ask me. But I hope the alternate one is easy, right? That you got it. At least that much to remember. Huh? This much they would ask. Without even giving the formula, you can handle this much. For alpha, you will need that Coriolis force and all that stuff. So what about that alpha thing? See, again, if you take the FBD of the small m, we have tension. We have mg cos theta. We have mg sin theta. So this is the only tangential force. So mg sin theta will be m into the tangential acceleration. So remember, the tangential acceleration has two components. R alpha plus 2v radial omega. Generally, we used to ignore the 2v radial because the length used to be constant. But now, since the string is moving, there is also a v radial. This will be m into r alpha plus 2v radial omega. This is the net acceleration, net tangential acceleration. If radius of the circle is constant, VR used to be 0. That's why we never bothered about that second term. You're getting it, but now the radius is not constant, R is changing. That's where the second term comes. I hope you're getting when to use the terms. In our portion, we have uniform circular motion and non-uniform circular motion. But if you observe the word circular motion, so it's still going in a circle. So R never changed. So we never had a problem. So this M goes off. This would be G sine theta. This would be R alpha. This will be 2. What is V radial? V radial is V cos theta. What is omega? V sine theta by L. There, you got everything. So from here, you'll get alpha. G sine theta minus 2V square sine theta cos theta by L 1 by R. That's your tangential acceleration, everyone. Clear with this? So angular acceleration is different, tangential acceleration is different. In circular motion, R alpha is tangential acceleration because this 2VR omega was 0. But if your circular radius is changing, then there are two terms for acceleration. So simple, I'll tell you, see. If you're going in a circle, this term and this term will never come, isn't it? Centripetal acceleration, tangential acceleration, you're done. If you're going in a circle, and if the circular radius is getting messed up, whatever is the reason, then this term and this term will come. As long as you remember this much, you will be able to handle the problems. So whenever you're dealing with situations where the radius is changing continuously, right, then you have to use that whole thing. Clear with this? This is one problem. It's a good one. Definitely try to do this again on your own. That will help, because it will look confusing. Until unless you do this once or twice on your own, you will not get the hang of it. You will feel like you'll understand, but once you try, you'll get stuck in the middle. So definitely try that again. Let's see one more. This was JEE 2016 का question. I don't think it is clear.
Sir, I think we did a similar problem today, no, back like a few lectures ago.
Can you guys read this? A little hazy, but I hope you can read this. So that is the thing. This is what I was saying. Whenever they ask you something now, they will give you this thing. I'll write down what they wrote here. So F net is F inertial, that is the forces in the ground frame, plus 2m v radial cross omega. This was your Coriolis force, Coriolis acceleration thing, plus m omega cross r bar cross omega. This is your centrifugal force. And so they explained all that story here. And then if you remember, we did something like this. It's not the same question. Let me put that whole question again. There, this was the question. There, these are the two questions. So the question is, find the distance of the block at time t and the net reaction of the disk on the block. So yeah, the equations are not bad, but I think currently at your level integration, you will have a problem. Do you guys remember this question? We found the speed when it is coming out.
Yes, so that is what I was saying. Like we did a similar type of question. Like we did this.
Shaurya, okay, Shaurya, focus on the class. Okay, let's not talk about no random stuff. What if it is you've done it already before? What is the point of discussing all that stuff? So if you have done similar problem, just tell me the answer, right? So send me your working, or else just keep quiet. Don't talk about random things, right? How is it even similar problem? I don't understand. Focus. You guys focus on all wrong things actually. So what to do with this? So this is the question. We kept the block at r/2. If you remember, there was a similar one. That's it. The similarity ends with the picture. After the question was something else. If you remember, I asked you find the speed when it comes out. Here they're asking what is the distance traveled as function of time t. So let me help you with this. Because like I said, this thing involves a bit of a calculus. Once they teach you in maths, it becomes quite easy, but for now it will be a little tough only. So let's say the block is somewhere here at a distance x. So what are the forces acting on the block? There is one force which is dragging you out. Let's start from there. M omega square x, that's your centrifugal force. We have done this part. So the centrifugal force is dragging you out, which is equal to mass into A. So A is equal to omega square x. This is V dV by dx is equal to omega square x. Clear? Then we integrate this. So v dv is equal to omega square x dx limits. It started 0 to v. It started from r by 2 to velocity distance x. This will be v square by 2. This will be omega square by 2. When you put the limits, you get x square minus r square by 4. So actually, once you write this equation, right, physics got over. In max, there is a much easier way to get the limits directly. But since they didn't teach you, I have to show you the whole thing for now. So this will be v is equal to omega root over x square minus r square by 4. So v can be written as dx by dt. So this will be dx by root over x square minus r square by 4. So remember that we need that velocity is equal to omega dt. So how do you integrate this? This will go from 0 to t, and this will go from r by 2 to x. So we have to use a technique called integration by substitution. Like I said again, don't worry about this, right? If you understood this, sufficient. After this, whatever came, right, is all pure max. So maximum they'll teach you next year. Then you will find it is quite comfortable. For now, it will be a little weird. So we use integration by substitution. We put x is equal to r by 2 sec theta. Dx will be r by 2 sec theta tan theta. So take this and substitute there. Dx becomes r by 2 sec theta tan theta d theta. Root over x square is r square by 4 sec square theta by r square by 4. This side will be omega t. That r by 2 comes out, r by 2 goes off. Sec square theta minus 1 is tan square theta. Yeah, it's lengthy. It is just working there. Sec theta ka integral is ln sec theta plus tan theta. Now this you should know. How can you prove this? You can differentiate and check it out. If you differentiate ln sec theta plus tan theta, you will get 1 by sec theta plus tan theta. Chain rule, sec theta ka differential is sec theta tan theta. Tan ka differential is sec square theta. Take out sec theta common, that will cancel out, you'll get sec theta back. That is only we can prove that. Is equal to omega t. When you put limits now, you'll get ln 1, so that term goes to 0. So you'll get sec theta plus tan theta is equal to omega t. But what is sec theta? Sec theta is 2x by r. That's what I said, it's more of a max. Tan theta is sec square theta minus 1, so that will be 2x by r whole square minus 1 is equal to omega t. Send it that side and square. 4x square by r square minus 1 is equal to omega t minus, this will be e power omega t. You're removing the log. Maximum, there's a much easier way. They'll use that e power I omega t and all that stuff, and you'll get it. So you'll get a quadratic equation. So when you solve this, let's write down the answer, you will get this one. So if you expand this and get the quadratic and solve, you'll end up with x by r by 4 is equal to e power omega t plus e power minus omega t. That much I will leave it there. Clear with this? It's lengthy. It's more of a max. Physics got over after you wrote this. And once you got that x, you can find the velocity, which is dx by dt. R omega by 4 e power omega t minus e power minus omega t. That's your velocity as function of time t. Why do I need that? For the second part. He's asking the net reaction on the block. Now remember, when you're going on a circle, and here the circle the block radius is also changing. You get two accelerations. So you are going in some circle here. So we have acceleration r alpha plus 2v radial omega. That's your net tangential acceleration. Who is providing it? This normal reaction nx. There's one normal reaction in the vertical direction ny, and there is an mg downward. So ny is providing your mg. Your nx is providing m into r alpha plus 2v radial omega. So the net normal reaction will be, one is vertical j cap and the other one is the, at this instant is asking, right? Yeah, he gave r by 2 y cap, so it is horizontal, it will be j cap. Alpha is 0 here because the thing is going with constant acceleration. So you'll simply end up with 2m v radial omega. And v radial is this one, r omega by 4. Substitute there and you'll get the second answer. Clear with this? Quite lengthy. Your seniors had a lot of difficulty with this. But one of his seniors was smart. He didn't know how to do. So what he did, he realized something. If one thing is clear, when you solve this equation, you will get something like this. P dv by dx is omega square x. Later on, we will see in SHM, if you get a is equal to minus omega square x, if you get a minus sign here, your life becomes really easy. The answer will be a sine omega t or a cos omega t. But if you put a plus, suddenly the whole thing goes for a mess. So one thing he realized, this is a plus. So it can't be cos, it can't be this. This much he realized. Then he didn't know how to solve this one or this one. There's a confusion. Now, if you clearly observe, if this was the answer, then this will match. But if this was the answer, then this will match. Did you notice? What did this guy did? He marked one here and he marked this one here. At least one will be right now. People had different ways of doing it. So if you can eliminate two options, you can come up with something like this. There, that is how you do this kind of. This is a 2016 question. It's a little more max oriented. This integration could have been done much faster if you actually know, but for now, this is the only way to do for us. Clear with this? So in Max-Min, you will get something called hyperbolic functions. So this integral can be directly written as a hyperbolic function. From there, you can create into an exponentials. Let max people handle it. We'll not get into that. So then you can skip all these quadratic equations and all, and you can directly get these exponentials. This is actually much faster if you know that. Yeah.
So we could have directly transposed the e to that side and used sec theta plus tan theta and sec theta minus tan theta.
Where you're saying here?
So we got sec theta plus tan theta. Now the reciprocal is
Yeah.
obviously e raised to minus omega t.
Because it is 1,
yeah.
वो भी कर सकते हो. There, he gave you one more good idea there. So, ठीक है, that also you could have done. I'll just write it down. Someone wants to try, you can try that. That is also a good one. Sec theta plus tan theta, we got e power omega t We know sec square theta minus tan square theta is equal to 1. There. So we got sec theta minus tan theta will be e power minus omega t. So if you add these two, we get 2 sec theta is e power omega t plus e power minus omega t. This was good. What is sec theta? Sec theta we wrote as 2x by r. Anyway, see, if you're good at maths, you find good answers. If you're bad at maths, like me, I would have solved that quadratic. Anyways, clear with this? You could have got that without that quadratic thing. There. So these last two problems which I showed you, right? If at all they ask you, they will give you that equation, but it is better to have an idea. So do try them, right? With that, we are done with the chapter. So when we catch up on Thursday, we'll start off with a new chapter, work power energy, quite an important one. Another base chapter, just like NLM was a base chapter for friction and circular motion, work power energy is a base chapter for the chapters going ahead. So we had done almost 32 questions, right? So do go through the whole notes. There were a lot of new things, different things. So solve, not tough, but you need to practice again. Okay, with that, we'll wrap up for the day. I'll see you guys again on Thursday, same time. So we'll start off with a new chapter. So any doubts, anything else, please stay back and ask, or else you're free to leave. So take care, stay safe.